Here we're going to graph the tangent and the cotangent functions. So let's remember or recall how the big six trig functions are defined. So remember sine of theta, that's defined to be y divided by r, and cosine of theta, that's defined to be x divided by r, and tangent of theta is y divided by x, cosecant of theta, that is r divided by y, and secant of theta, r over x, and finally cotangent of theta is x over y. Okay, so this is a good habit for you to get into, just rewriting the definitions of the big six trig functions because they occur so frequently. Now these first two functions, sine and cosine, are kind of special, and they are special because they are never undefined. Never undefined. Okay, why not? The reason is because the denominator is r, right? And r is the radius of the circle, and the radius of the circle is never 0. But these other four functions, right? These four, notice that they have either the x-coordinate in the denominator, right? Or the y-coordinates in the denominator. In that case, they can be undefined. Sometimes these are undefined. So these four functions here, they're a little different than sine and cosine, right? They can be undefined. Let's write that down. These can be undefined when the denominator is 0, of course. Now, it turns out, as we're going to see, that everywhere these functions are undefined, they have vertical asymptotes. Let's write that down as well. So these have vertical asymptotes. Where they are undefined. Okay, now what we mean by the phrase vertical asymptotes is we mean that the y-coordinate either gets large, either goes to infinity or goes to negative infinity. Now, to explore those ideas, vertical asymptotes, we are going to think first about fractions. Now that kind of makes sense because if you look at all the definitions of the trig functions, after all, they are simply fractions. So let's make an observation about fractions. So if you consider the fraction, let's go with 0.5 divided by 0.1. Well, if you divide 0.5 by 0.1, you get just 5. You can move both decimals in one place, and then you get 5. Now, if you take 0.9 and you divide that by 0.01, right? Well, now you move both decimal places twice to the right, and you get 90. Okay, and then if you take 0.99 and divide it by 0.001, you get, well, three places, you get 990. And let's do one more. If you take 0.999 divided by 0.0001, a lot of zeros, you're going to get 9990. Okay? Now, what's happening here? Well, a couple of things. First of all, do you see how I'm making the numerator close to 1? And I'm making the denominator close to what? Close to 0, right? So the first thing I'm noticing is that we're going, the numerator, this little arrow means heading towards, okay? The numerator is heading towards 1, and the denominator is heading towards 0. I'm not saying 1 divided by 0, that's undefined. I'm noticing what happens as you get close, as you head to 1 over 0. As you head to 1 over 0, this is going to infinity. That fraction's getting larger and larger, okay? So this is the notation we're going to use. As the fraction goes to 1 over 0, this fraction heads to infinity. Now we can also play a similar game by making one of these negative, for example, or both of them negative even if you want. Let's just see what it looks like if one of them is negative. So let's say you had 0.5 divided by negative 0.1. Well, positive over a negative is a negative, and it's going to be just negative 5. And then likewise 0.9 divided by negative 0.01 is going to be negative 90. And 0.99 divided by negative 0.001, that's going to be negative 990. Finally, 0.999 divided by negative 0.0001. Okay, what do we get? Well, it's going to be negative 9990, okay? And just, as a notational thing, you'd say, oh, once again, still heading towards, this is heading to 1, and the denominator is heading to 0, and I got negative infinity in this case, right? So I still got a brand of infinity, if you will. So it's that combination of when the numerator goes to 1 and the denominator goes to 0 that you either get infinity or negative infinity. Now you might say, wait, this is a little bit confusing because you wrote 1 over 0 and positive infinity, and over here 1 over 0 again, but negative infinity. And I agree with you. So we're going to need a little more notation to make clear that these are actually different scenarios, right? So here's the idea. If you had a number line, and this is the number 0, okay, and you had 0.5 right here, and then 0.1 like that, okay, I'm approaching 0, right? But I'm approaching 0 from the right. That is, I'm coming in from the right of 0. You can write that with a little 0 and a little positive sign. That means you're approaching from the right. You're getting, yeah, you're going to 0, but you're coming in from values a little bit larger, right? That's what the plus means, a little larger than 0. And if you went from the other direction, negative 0.5 and then negative 0.1, you'd say, oh yeah, you're approaching 0 all right, but you're coming from values a little bit less than 0, okay? And we say approaching from the left, okay? Now that means that, yeah, I was approaching 0 down here, but would you say I was approaching from the right or from the left? Well, I was approaching from the right because all the denominators, right, yeah, they're going to 0, but they're a little bit larger than 0. So I was approaching 0 from the right. Okay, and that's a little plus sign. Hope you can see that. So, and that's why, a positive over a positive gave positive infinity. But in this scenario, the denominator was certainly approaching 0 once again, but the denominator is approaching 0 from the left because all the values were less than 0. And a positive over a negative always gave rise to a negative quantity, and that negative quantity was approaching negative infinity as this occurred. Okay? So this is our notation. So two things to notice, and it's that 1 over 0, when you get towards that, you're either going to get positive or negative infinity, and whether you get positive or negative infinity all depends if the denominators were positive or if the denominators were negative. Okay? So with that in mind, let's go ahead and graph tangent. Lots of background for this one. I know, it's kind of confusing. Okay, so we're going to graph tangent. Now the graph of tangent is going to occur down here, but we're going to use the circle to generate this graph. So remember what tangent of theta is. Tangent by definition of the angle is, well, it's y divided by x, okay? So now you can choose any size circle you want. Let's choose the unit circle. So that would be when the radius is 1. Now if the radius is 1, this point would have coordinates, well, x is 1 and y is 0, and this point would have coordinates x is 0 and y is 1. This point would have coordinates x is negative 1 and y is 0. And this point likewise would be x is 0 and y is negative 1. All right, so now let's go ahead and just get some values that are easy. So y over x. So, is there anywhere where y divided by x is 0? Well, yeah, sure, right? Here the y coordinate is 0 and the x coordinate is 1. So tangent of 0, that is 0 degrees, is 0 divided by 1, which is just 0. So when the angle, which is on this axis, when the angle is 0, tangent is 0. So I get 1 point right away. That was pretty fun. Okay, now what about the angle pi over 4? Well, pi over 4, let's go ahead and draw that angle in. This is one of our fun angles, right? Maybe fun's a strong word, but... Okay, so anyway, pi over 4 is 45 degrees. So I can draw in the 90-degree triangle. This is 45. This is 45. And this, if this point has coordinates, if the hypotenuse is of length 1, remember this point has coordinates root 2 over 2, root 2 over 2. That is those are these lengths, and they're both positive. So what is tangent of 45 degrees? Well, it's y over x. So y, root 2 over 2, divided by x, which is the same thing. So y over x is simply equal to 1. Let's go ahead and plot that point. When the angle is pi over 4, tangent of pi over 4 is 1, so right about there. Okay, now, things get a little interesting as we approach this angle pi over 2. Now, would you say here that I'm approaching pi over 2 if I'm walking in like this on the number line? Am I approaching pi over 2 from the left or from the right? Well, clearly I was approaching from the left, okay? So here's what we're going to do. We're going to let the angle theta approach pi over 2, like we approached 0 before, right? But we're approaching pi over 2 from the left. Now, we're heading from 0 to 45 to pi over 2, and that would correspond to 0, pi over 4, pi over 2. This is how you approach pi over 2 from the left as you're going along the unit circle, right? Just like this. I'm approaching, now we say from the left because it refers to this number line, but it's a rotation like this, okay? So let me ask you, as the angle approaches pi over 2 from the left, what happens? Well, I can see that what's happening to y over x is the question. Well, y over x is heading towards, well, what's y getting closer to? Y is getting closer to 1, and x, right, as this point comes in like this, the x coordinate is getting closer and closer to 0. So it's 1 over 0. Okay, now we know that this is either going to be infinity or negative infinity. It's time for us to make this more precise. Sure, y is approaching 1, but how is x approaching 0? Would you say the x coordinate of this point is going from 0 to the right or from the left? Well, here's the x-axis, right? And here's 0. And so the x coordinate is clearly getting smaller and smaller, right? But it's doing so through positive values on the x-axis. So I'm going to put a little plus sign right there. And we know what happens when you approach 1 over 0 from the right, that little plus, that is going to positive infinity. So what's happening is, as the angle gets closer and closer to pi over 2, tangent is looking like this. The output is going, whoa, it's going to positive infinity, right, as the angle approaches pi over 2 from the left. Now that's of course what we mean by a vertical asymptote. So this function has a vertical asymptote at pi over 2. Let's do that. Let's draw in the vertical asymptote and then sketch the graph getting closer, getting larger and larger towards infinity as the angle goes to pi over 2 from the left. Let's graph that in now. Okay, so that's part of the graph of tangent. You can see I have the vertical asymptote here, and we usually draw vertical asymptotes dotted, and I can see that the function is skyrocketing. The y-coordinate's getting larger and larger as the angle approaches pi over 2 from the left. Now what happens as you go the other direction? Let's approach negative pi over 2. Would you say we're approaching negative pi over 2 from the right or from the left? Well, certainly from the right, yeah? So let's do that. We're going to let theta approach negative pi over 2, but from the right. Okay, now the question, what happens to y over x? Well, we're coming in like this, right? So y over x, what's y doing? Well, y is getting closer to negative 1, right? And x is going to, well, 0 once again. So we know we have either infinity or negative infinity, right? The question is, how are you approaching 0? Well, let's see. The x-coordinates, as you come in like this, the x-coordinates are always going to be positive, because once again, it's this part of the x-axis, right? So the x is approaching 0 from the right, and that's why the quotient, a negative over a positive, that quotient is approaching negative infinity. So that is, as the graph comes in, as the angle approaches negative pi over 2 from the right, the tangent is looking like this. And you can see, of course, that tangent of pi over 4 is 1, and likewise tangent of negative pi over 4 is negative 1, right? That would be down here, right? Negative pi over 4, let's draw that in, that might be helpful. So this will be pi over 4, and the coordinates of this point are going to be, well, x is root 2 over 2, but y is negative root 2 over 2. So y divided by x is negative 1, and that's why tangent is negative here. But as the angle approaches negative pi over 2, the y is going to negative infinity, and it's going to look like that, okay? So now let's draw in that vertical asymptote and that portion of the graph. Okay, so this would be the other branch of tangent. So all of this together, that is one cycle of tangent. Now just one note here, that the graph is not flat here like x cubed. It really looks more like a slope of 1 there. So the graph looks more like that. Yeah, it's going to infinity, but it never quite flattens out right there. The slope is equal to 1 right there. Now, I went ahead and put in another vertical asymptote over here. So I know that's going to be a vertical asymptote because remember, tangent is y over x, and at 3 pi over 2, you can see that's 3 pi over 2, which is here, I can see the x-coordinate is 0. And so the function is undefined, and I mentioned earlier that wherever it's undefined, it has a vertical asymptote. Now, let me go ahead and just show you what the graph looks like over here. It turns out the graph is actually going to look like this again. So it's basically going to be this shape, just repeating. But why? Why does the graph look like this as you approach pi over 2? Well, the angle, remember, is along this axis. So the angle here is approaching pi over 2 from the what? From the left or from the right? Well, from the right. Let's go explore that. So we're going to let the angle approach positive pi over 2, right? From the right. What happens to y over x? Well, let's see. Where's positive pi over 2? It's here. You need to be really careful, right? Because approaching pi over 2 from the right, that means that you're coming at it from angles that are larger than pi over 2. But where are the angles that are larger than pi over 2? They're over here, right? So we're approaching pi over 2, we're rotating in this direction. That's very subtle. We're approaching pi over 2 from angles that are larger than pi over 2. Y over x, of course, is still heading towards 1 over 0. But how is x approaching 0? Well, you're coming in like this. Are the x-coordinates of these points positive or negative? Well, it's this part of the x-axis, right? And the x-coordinates are negative. So even though the x is approaching 0, all the x's are negative. And that's why x is approaching 0 from the left. And that means this quotient is going towards, well, positive or negative infinity. Which one would it be? It'd be negative infinity, right? And that's why as you approach pi over 2 from the right in this direction, that's why the graph is looking like this. Whoa, that's subtle. Okay, so we're going to get another cycle of tangent. So let me go ahead and graph that for us now. Okay, so there's another cycle of tangent. Now you can see that tangent just keeps repeating this pattern over and over, right? Now how far does it have to go to repeat the pattern? That is, what's the period of tangent? Well, the difference between pi over 2 and 3 pi over 2 is pi. So the period of tangent, it's not 2 pi, it's pi. And what's the domain? Well, the domain, you can plug in any angle you want except where you have vertical asymptotes, right? So let's do that up here. Where do you have vertical asymptotes? Let's use that. Well, the vertical asymptotes occur, let's see, at pi over 2, 3 pi over 2, another one at 5 pi over 2, and so on. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi, and do you see a pattern arising? The next one would be 9 pi over 2, right? And then also negative, right? So it's going to be negative pi over 2, negative 3 pi over 2, and so on. Now what I'm doing is I'm listing odd multiples of pi over 2, right? 1 pi over 2, 3 pi over 2, 5 pi over 2, and so on. And we write that like this. Vertical asymptotes occur when x is equal to an odd number. Now odd numbers, any even number can be written as 2 times k, where k is an integer. Like for example, 14 is 2 times 7, and 20 is 2 times 10. Any odd number can be written as 2 times k plus 1. So for example, can you think of a way of writing the number 13? Well, 13 would be 2 times 6 plus 1. So we write the odd numbers in the following way. 2k plus 1 multiplied by pi over 2, where k is an integer. And by an integer, we mean negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. So if you plug in any k, any integer right here, multiply it by 2 and add 1, that gives you an odd number. And any odd multiple of pi over 2 gives you a vertical asymptote for tangent. Okay, so with that in mind, the domain, let's write this down here, the domain of our graph, it's all numbers, so all real numbers, except where you have vertical asymptotes, right? Those are clearly not in the domain. And what's the range? Well, the y can go all the way from negative infinity all the way to positive infinity. So it's negative infinity to positive infinity. Okay, lots going on with tangent, right? Now, closely related to tangent is cotangent. Let's graph that now. Okay, so what I did is I drew our unit circle once again. And let's go ahead and now we know where the vertical asymptotes are going to occur, right? Everywhere cotangent is undefined. So cotangent is, it's not y over x, it's x over y. So let me ask you, when is y 0? That's where you're going to have vertical asymptotes, right? Y is 0 right here, and it's also 0 there. So here it's at no longer odd multiples of pi over 2, but odd multiples of pi, right? Let's write that down. You have vertical asymptotes whenever x is equal to any integer multiple of pi, so k times pi, where k is an integer. So for example, 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. Negative pi, negative 2 pi. And so basically at these points, but different angles, right? And all those angles can be written in this really compact way. X is equal to k pi. Okay, let's go ahead and put those vertical asymptotes in at 0 and at pi and at negative pi. Let's do that now. Okay, so there are vertical asymptotes. Now let's look at where cotangent is equal to 0. Well, if cotangent is x over y, that's going to occur when x is 0 and y is 1. That would be here, right? There's one place, x is 0, y is 1. Here's another value. Now what's this angle? Well, from here to here, that would be just pi over 2, right? So at pi over 2, cotangent is 0. And this angle, right, all the way around, that would be 3 pi over 2. So that would occur over there. Or you can view it in the following way. Negative pi over 2, so cotangent is 0. Okay, why don't we go ahead and look at the graph of cotangent between 0 and pi. And you can guess that cotangent is going to look a lot like tangent, but a little different. So let's see what happens as you get close to the vertical asymptote. Let's first see what happens as we get close to 0 from the right. So let's write that down. The angle is approaching 0, but from the right. Okay, so we're coming into the angle like that. Well, what are we looking at? X over y. So x over y is heading to what? Well, x is heading to 1, and y is heading to 0, right? Now I'm coming in from the right, so I'm coming in at angles that are larger than 0. So I'm coming in to 0 from the right, and we know that goes to infinity. And that's why when you come into 0 from the right, the graph is looking like that. Whoa, right? Skyrocketing upward. And what do you think is going to happen as you approach pi, but from the left? You got it. The graph is going to look like this. It's going to go to negative infinity. Let's go ahead and verify that. Let's see what happens as the angle approaches pi from the left. So if angle approaches pi, but from the left, what does x over y do? Well, let's see. That's tricky. Pi from the left. Well, here's pi. Now, angles that are less than pi would be up here. So here we go. What's x doing? Well, x is going towards negative 1, and y is going to 0. Now, the y's are positive because we're positive on the y-axis, right? So as you come in like this, yeah, x is going to negative 1, y is going to 0, but through positive values once again. And that's why this quotient is going towards negative infinity as we guessed. So we're going to positive infinity this way and negative infinity that way. Let's go ahead and graph that in now. Okay, so there's the graph of cotangent. And notice that the period is also pi. Now you should go ahead and try to graph in the cotangent over this interval, and you'll find that you get this part of the graph, right? So you'll find that you get another graph looking like this, right? So cotangent, basically like tangent, keeps on repeating this pattern, these patterns over and over. So once again, the domain is all reals except where you have vertical asymptotes, and the range is once again negative infinity to infinity. Okay, whew, that was a lot of work. So these are the graphs of tangent and cotangent, and they look very similar. And remember, they have vertical asymptotes, and those are sort of our key points, two of our key points when graphing these. By the way, this would be the main cycle over which we graph cotangent. And notice that cotangent of pi over 4 is equal to 1, and cotangent of 3 pi over 4 is equal to -1. So these would be considered key points as well. Okay, until next time.